I'm starting with a grayscale image. Imagine a 100 pixels by 100 pixels square picture in black and white. I'll use Sklearn's PatchExtractor tool. This tool is like a cookie cutter for images. It cuts out smaller squares, patches, from a bigger image. The patch_size tells it how big each cookie should be, and the patch_stride tells it how far apart to place the cookie cutter. I'm setting the patch_size to 10 by 10 pixels. That means each patch will be a 10 by 10 pixel square. The patch_stride is set to 5 pixels. This means that the tool will move the cutter 5 pixels to the right or down before cutting out the next patch. The output is a 3D array. Think of this as a stack of square images. There are 19 times 19 equals 361 patches in total. Each patch is a 10 by 10 pixel square, so the output dimensions are 19, number of patches along one side, 19. Number of patches along the other side, 10. Height of each patch, and 10. Width of each patch. Each of these 361 patches will be a perfect 10 pixels by 10 pixels square, as specified by the patch_size parameter. This option is wrong. It incorrectly calculates the number of patches, using 18 instead of 19 patches per axis. I calculate the number of patches along each axis like this. Image_size, patch_size, patch_stride plus 1 equals 100 to 10, 5 plus 1 equals 19. This is correct. It accurately matches my calculation of 19 patches along each axis, giving a total of 19*19 patches. This is also correct. It reflects the patch_size I set earlier. This is wrong. The PatchExtractor always gives a 3D array. It's not a 2D array. I'm working with a grayscale image. It's a square image, 100 pixels wide and 100 pixels tall. Think of it as a 100 by 100 grid of grayscale values. Here, I set up the parameters for the PatchExtractor. Patch_size is set to 10, meaning I want to extract square patches that are 10 pixels by 10 pixels. Patch_stride is set to 5. This means each patch is shifted over by 5 pixels from the previous patch. I've explained these in the previous row. This is where the magic happens. I use the PatchExtractor with the parameters defined above to break my large image into many smaller 10 by 10 patches. Each individual patch that I extract from the big image will be a 10 pixel by 10 pixel square. That's what the patch_size parameter controls. The PatchExtractor gives me a 3D array as output. It has 3 dimensions. The first dimension represents the total number of patches, which is 19 times 19 equals 361. The other 2 dimensions represent the size of each patch, 10 by 10. So, I'll have 361 patches, and each patch will be 10 by 10 pixels. Pretty cool. I'm working with a grayscale image. Think of it as a black and white picture, 100 pixels wide and 100 pixels tall. I want to divide this image into smaller squares, each 10 pixels by 10 pixels. These squares are my patches. I'll slide the 10 by 10 window across the image. Instead of moving it 1 pixel at a time, I'll move it 5 pixels at a time. This is my stride. Think of it like taking steps of 5 pixels. The result is a 3-dimensional array. It's like a stack of pictures. The first dimension shows how many patches I have. 19 times 19 equals 361. Each of these is the 10 by 10 patch. I use Sklearn's PatchExtractor, which is a tool that does all this patch extraction for me automatically. To figure out how many patches I get along each edge of the image, I subtract the patch size, 10, from the image size, 100, divide by the stride, 5, and then add 1. The operator means integer division, so I only get whole numbers. This gives me 19 patches along each side. Every patch that I extract will have dimensions of 10 pixels by 10 pixels, as I have already specified. I'm using Sklearn's PatchExtractor to understand how it works. It's a tool that pulls out smaller square sections, patches, from a larger image. I'll be working with a grayscale image that is 100 pixels wide and 100 pixels tall. Grayscale means the image only has shades of gray, no color. Here, I'm setting the size of each patch to 10 pixels by 10 pixels. The stride of 5 means that I'm moving the patch 5 pixels at a time when I extract each subsequent patch. Think of it like taking steps of 5 across the image. The patch extractor gives me back a 3-dimensional array. This means that the output is structured with 3 layers of numbers, not just a simple grid. The 3D array's shape is 19 by 19 by 10 by 10. This means I'll get 19 times 19, 361 total patches, each being 10 pixels wide and 10 pixels tall. I calculated this by figuring out how many times my 10 by 10 patch will fit into a 100 by 100 image while stepping 5 pixels at a time. Each patch that I extract will be a 10 by 10 square. This is exactly what I specified using the _patch_size parameter. The output is structured in 3 dimensions. The first dimension shows how many patches I have in total, and the next 2 dimensions are 10 by 10 to represent the patch size. I'm using Sklearn, a powerful Python library for machine learning, and specifically its PatchExtractor tool. This tool is awesome for grabbing smaller sections, patches, from a larger image. Think of it like taking little snapshots from a big picture. I'm starting with a grayscale image, meaning it only has shades of gray, no colors. That's 100 pixels wide and 100 pixels tall. I want to extract square patches that are 10 pixels by 10 pixels. The stride tells me how many pixels to skip between each patch. A stride of 5 means I move 5 pixels to the right and 5 pixels down before taking the next snapshot. It's like taking steps of 5. The result of the extraction will be a 3D array. Think of it as a stack of my 10 by 10 patches. A 3D array has 3 dimensions. The first dimension is how many patches I have, the second and third are the 10 by 10 dimensions of each patch. This tells me the exact size of that 3D array. I have 19 patches across and 19 patches down. 19 times 19 equals 361 total patches, and each patch is 10 by 10 pixels. It's like a grid of images within an image. The calculation is 100 to 10, 5 plus 1 equals 19, which gives the number of patches per dimension. The double slash means integer division. Here's a multiple choice question to test your understanding. Now, let's see if you understood the previous steps. It's quiz time. This answer is wrong because it incorrectly calculates the number of patches. This is the correct answer. It matches the 19 by 19 patch grid we calculated. Woohoo! This is also correct. It's directly given by the patch size, 10 by 10. This is wrong. I already told you the output is a 3D array. I'm using Sklearn's PatchExtractor, a tool that helps me extract smaller pieces, patches, from a larger image. It's like taking a big jigsaw puzzle and cutting it into smaller, manageable sections. I'm starting with a grayscale image, a black and white picture. That's 100 pixels wide and 100 pixels tall. Think of it as a 100 by 100 grid of tiny squares. Each patch I want to extract will be a 10 by 10 square of pixels. That's like cutting out 10 by 10 sections from my bigger image. The stride is how many pixels I move the window before extracting the next patch. A stride of 5 means I'll slide the 10 by 10 window 5 pixels to the right and 5 pixels down before grabbing the next patch. This way patches overlap each other. It's like stepping through the image with big hops. The result will be a 3D array. The first number, 19, tells me how many patches I'll get in each direction, horizontally and vertically, because 100 to 10, 5 plus 1 equals 19. The next 2 numbers, 10 and 10, are the dimensions of each patch, 10 pixels by 10 pixels. So, I get a total of 19 times 19 equals 361 patches. This answer is wrong because it incorrectly calculates the number of patches. It doesn't account for the last patch we extract. Think of extracting patches from the image. If we stop after 18 patches, we miss a whole row and column. Oops. This is the correct answer. It accurately shows that we get 19 patches in each direction, 19 by 19 total, and each patch is 10 by 10. This is also correct because each extracted patch maintains the same 10 by 10 dimensions. This is incorrect. the patch extractor always outputs a 3D array to represent the collection of patches, which is a three-dimensional structure. I'm extracting image patches. Think of it like taking smaller snapshots from a larger image. This is a crucial step in many image processing tasks, such as feature extraction. It helps you analyze the images more effectively. I have a grayscale image, 100 pixels wide and 100 pixels tall. It's like a black and white photo. I'm setting up my patch extraction tool, specifically the size and spacing between the patches. PatchExtractor equals 10 means each patch will be 10 pixels by 10 pixels, which is like a tiny square snapshot. PatchExtractor equals 5 means that each snapshot moves 5 pixels from its previous location. Think of it like stepping across the image. I'll end up with a 3D array. The first two numbers show how many patches I have, 19 rows by 19 columns. The last two numbers refer to each patch's dimensions, 10x10 pixels. It's a big array of tiny images! Exclamation mark. Each individual patch that I extract will be a small 10 by 10 pixel square. That's like a little mini picture inside my larger image. I'm using a pre-built tool from Sklearn, a popular Python library for machine learning, called "PatchExtractor". It's my go-to tool to make this extraction process simpler. I'm now ready to check my understanding by answering a multiple-choice question about the output I should expect from my patching process. This tests my knowledge of the tool and how the parameters affect the result. This question tests my ability to understand the output shape and size, and how I would expect it to change based on the image size and my "patch extractor" parameters.